Today's lesson is on solving two-step equations with distributing and combining like terms. We're also going to take a look at some field properties of equality. Our first field property is the reflexive property of equality, which just states that A equals A. So if I have a number 5 on the right side of my equation, it will equal the value of 5 also on the left side. The symmetric property of equality states that if A equals B, then B equals A. We're going to pretend that A is equal to 2 plus 3, and we'll say B is equal to 1 plus 4. So we're just replacing these variables with an expression. So if A, 2 plus 3, equals B, 1 plus 4, 1 plus 4 is equal to 2 plus 3. Our next one is the transitive property. I'm going to use the same numbers here as replacement values for A, for B, and for C. I'm going to say 5. The transitive property states that if A equals B and B equals C, then A equals C. For example, if I had 2 plus 3 equals 1 plus 4, and I said that 1 plus 4 equals 5. I could also say then that 2 plus 3 equals 5. That's your transitive property. I put a star on that because I see that a lot on your SOL tests. We've worked with the substitution property of equality. If A equals B, then A can be substituted in for B. So if I had the equation of 2x plus 3 equals 8, and I wanted to replace your value, I tell you that x, is equal to 2.5. We're just substituting in that value. The next few properties can be a little bit tricky, only because, remember, we're talking about equations, and when we solve equations, we do the inverse operations. So for example, we have the addition property of equality, which states that if A equals B, then A plus C equals B plus C. You already know this. Let's say we had an equation of x minus 6 equals 4. What would you tell me that you would do to both sides of this equation? You hopefully would tell me that you would add 6 to both sides. By adding 6 to both sides, you're using the addition property of equality. For the subtraction property of equality, we actually have addition in our problem. If we were to solve this equation, we would be subtracting 8 on both sides. That's showing the substitution property of equality. For the multiplication of equality, we actually have a division problem. So I'm going to say C divided by 2 equals 6. In order to solve this, we multiply by 2 on both sides. And we did this last class as we were solving 1- and 2-step equations. The division property of equality is when we have multiplication in our problem. So here I'm going to have 5d equals 10. In order to solve this, we would divide by 5 on both sides. So we didn't solve these equations that we wrote down, we just were demonstrating the field properties. When we solve two-step equations, we want to clear our parentheses. So we might distribute, or we could divide by the outside number. We talked about that last class. We might end up combining like terms if necessary, and then we do the add and subtraction first, multiply, divide last. So take a look, we practiced these last time, where we have a number outside. We can either take the time to distribute, or we can multiply by its reciprocal. So last class we said we would go ahead and take that outside number, and because 4 is being multiplied by the parentheses, we're actually going to just divide by 4 and work that way. When we divide by 4, we're left with x minus 6, and we no longer need the parentheses, and 32 divided by 4 is 8. Now we have just addition and subtraction in our problem, so we're going to go ahead and add 6 to both sides and get an answer of 14. we absolutely should check. And when we check, we're using the order of operations. 4 minus 6, 14, excuse me, minus 6 is 8. 8 times 4 is the next step, which is 32. We also can work with the fractions outside of parenthesis groups. Here we said we would multiply by the reciprocal. So the reciprocal of 2/5 is going to be 5/2. We did talk about this last class. Those reciprocals on the left side cancel each other out because they simplify to one whole. And in this case, we have x plus 2 equals, I'm going to put a little 1 under my 8. 8 times 5 is 40. 2 times 1 is 2. 40 divided by 2 is 20. Now I have a one-step equation where I get rid of that addition by subtracting. And we'll have a value of 18 as our answer. We can check that again by plugging in and using that substitution property to double check our work. Put a little 1 under there. 2 times 16 divided by 5. Let's double check that. Did you catch my mistake? I said 18 plus 2 is 16. I subtracted there. So double check your work. This should be a 20. 2 times 20 is 40. 5 times 1 is 5. 40 divided by 5 is 8. So that works out. Go ahead and pause your video and try the next two. Take a look at the work up there and pause the video again if you want to go back and check it. When we move on to combining like terms, this is just making a collection of all the variables that you have. We treat those variables work like it's integer work, where we're just combining or adding together the variables that are the same. So for example, I have 3x's plus 2x's. Well, if I have 3x's or 3 xylophones and I add it with the 2 xylophones that my friend has, now we have 5 xylophones. So we combined our like terms there. We're combining like terms that are on the same side of the equal sign. Then it's just a one-step equation. And we can check because we're going to plug in that value for every single x. 3 times 3 is 9. 2 times 3 is 6. And when we combine that, we get 15. Our next one has a little extra, so let's take a look at that. Again, we're going to combine the variables that are the same. So I have 7 xylophones, and then I broke 4 xylophones. So now I'm down to just 3 xylophones. I still have to deal with that minus 3 equals 21. So now it's a two-step equation. We're going to add 3 to both sides first. And then divide. And we get our value, x equals 8. Always, again, double check by taking your variable and replacing it with the value that you found. Follow the order of operations as you work. And I'm just showing all of my steps there. Go ahead and pause the video and you can try the next two. Double check your work with what you have up there. If you need to, go ahead and pause the video. We're going to put together both distributive property and combining like terms in our next couple of examples. So for our next one, we're going to start off by, we can either distribute, we can't divide right away. We can move this term minus 5 to the other side. We're going to go ahead and do our distribution first, and then we'll see how we can combine like terms. Negative 7 times 8 is negative 56x. Negative 7 times a negative 1 becomes a positive 7. Combine what you have alike, which is just your numbers here. So we've got negative 56x, and we're going to combine 7 minus 5, which is positive 2. Now we have a two-step equation. We're going to subtract 2 on both sides. Then we can divide by negative 56. And we should get an x value of negative 2. Confirm by doing your check, and you can take a look at it there. For our next example, again, we're going to go ahead and do our distribution first to clear those parentheses. So we'll have negative 16n. Remember that a negative times a negative is going to give you a positive 4. And then we have minus 7n. We're going to combine our variable terms this time because they are like terms. So I've got negative 16 and a negative 7, which is going to give us a negative 23n plus 4. Our next step, now that's a two-step problem, is to go ahead and subtract 4 on both sides. And our last step would be to divide. We're going to divide by negative 23 on both sides. And we'll have 6 equals n, which you can write, now that you know your properties, as the same thing as n equals 6. Symmetric property. And go ahead and pause the video and do your check. Okay, confirm with your check it's there. And then I'm going to ask you to go ahead and try the next two problems. Pause the video, work them out, and then take a look at what you see on the video. We can also have applications of equations with word problems. So we'll take a look at 2 more application problems. 3 friends went out to lunch. They each started with the same amount of money, and they each spent $6. They ended with a combined total of $24. How much did each of them have to start with? This is a tricky one. So we know that 3 friends went out to dinner and they each started with the same amount. So we can have that same amount be x. They each spent $6. So if they had a certain amount of money and then they each spent $6, they're subtracting $6 from their total. How many friends went out to lunch? How many friends are we talking about? We're talking about 3. So if each of them started with a certain amount of money and we spent $6, we can take what they have left and multiply it by 3 to get to the total. So we're going to put a big 3 out here. And we know that they have a combined total now of $24. Your equation would look like this. 3 times x minus 6 equals 24. And then from here, we can decide how we want to solve it. We can either distribute or we can divide everything by 3. I'm going to choose to divide everything by 3 here. And we'll get x minus 6 equals 6. Add 6 to both sides, and we'll get a value of 12. Each friend brought $12. The next word problem says a total of 234 tickets were sold for the school play. There were either adult tickets or student tickets. The number of student tickets sold was 2 times the number of adult tickets. So we're going to represent our adult tickets with an x. So the number of student tickets is then 2 times the number of adult tickets. So we can represent that as just 2x, twice as many student tickets, or twice as many adult tickets, I should say. How many tickets were sold? Well, we know there were a total of 234 tickets. We want to know how many adult tickets were sold. So we're going to set up an equation of the amount of adult tickets plus the amount of student tickets will equal 234. Combine your like terms and divide by 3. Remember too that when you're solving a word problem, your answer should have some words in it. So as we solve this one and we do 234 divided by 3,